Solve systems of equations by graphing. Student learning objectives. Define system of linear equations in two variables. Solve system of linear equations in two variables by graphing. Discuss possible solutions of systems of linear equations in two variables. Define system of linear equations in two variables. Two linear equations in two variables is called a system of linear equations in two variables. The solution to the system is an ordered pair that is a solution to each equation. When graphing, the solution is the point where the two lines intersect. Solve the system of linear equations in two variables by graphing. So we have the following equations in the system, and we want to solve it by graphing. So the point where the two lines in the system intersect will be the solution. So we're going to graph x plus y is equal to 5, and x minus x plus y is equal to minus 5. So we have a rectangular coordinate system here. And we're going to graph each point by using their x and y intercept. So for the first equation, the x-intercept is when y is 0, x is 5. The y-intercept, when x is 0, y is 5. So we graph the 2 points. Five, 0 is this point here. 0, 5 is this point here. And connect the two intercepts and extend the line beyond. And that is the graph of x plus y is equal to 5. To graph the second equation, we do the same thing. We use x and the y-intercept. So x-intercept, when y is 0, x is 5. The y-intercept, when x is 0, y is negative 5. So 5, 0 is here, this point, and minus y-intercept is 0 minus 5 is the second point here. Connect the two intercepts, x and y-intercept, and extend the line beyond. And this is the line for the second equation, which is minus x plus y is equal to 5. The point of intersection is 5, 0. So the solution to this equation, we solved it by graphing, and the intersection is 5, 0. So that is the solution to the system. Discuss the possible solutions of systems of linear equations in two variables. Excuse me. If the equations in the system are parallel lines, then the system does not have a solution. In this case, the equations are said to be independent and the system is inconsistent. So given two equations and two variables in a system of linear equations in two variables, if we graph the two lines in the system, and if they turn out to be that they do not intersect, when they don't intersect, they are parallel lines. That means they don't have a solution. In this case, we say that the system is inconsistent and the equations are independent. Another possible solution: if the equations in the system intersect at one point, the system has one unique solution. So if we graph the equations in the system, then the equations intersect exactly at one point. Okay, line 1 and line 2, this is, let's say, their intersection. So that means they have a unique solution. They have one solution. In this case, we say the equations are independent and the system is consistent. Another possible solution: if the equations in the system are the same line, the system has infinitely many solutions. So the equations written in the system are the same lines, meaning they're written differently, but they're the same lines. So when you graph them, it happens, the lines happen to coincide. That it means it's the same line that we're drawing. So this system has the lines intersect infinitely many times. That means it has infinitely many solutions. Therefore, we say that the equations are dependent and the system is consistent.